again, it's Professor Johnson, and in this video I would like us to walk through doing an independent groups t-test in SPSS. So this is a t-test for a situation where you have between subjects independent variable. That is, whoever is in group A, that's the only value they give us, and for the people in group B, that's the only value they give us. I'm just assuming at this point that you know when it's appropriate to use a t-test. We have a between subjects IV with two levels. Our dependent measure needs to be interval or ratio. We make some assumptions to do these tests, including homogeneity and the normality assumptions, as well as independent and random samples. When you enter data in SPSS, this is one place where you need to be careful. There's going to be two columns in data to do an independent groups t-test. The first column is going to indicate, using a numeric code, which condition a particular score comes from. So condition 1 will be a 1, condition 2 will be a 2, placebo would be a 1, drug would be a 2, high stress could be a 2, low stress a 1, however you want to set it up. But this is truly a nominal variable usually, but we're going to use a numeric code for it, and then we'll use value labels to help our output make more sense to us. And then our dependent variable will be the second column. So each person will have two values for them. One will be indicating which condition they're in for the independent variable, and the second value will be how they scored or what we measured from them. Let's imagine a situation where we're looking at students who are taking a course in Introduction to Neuroscience, and in one condition we do not give them any sort of study advice, or alternatively this could be a control condition where you give them standard study advice. And in another condition we talk to them about concept mapping and how to use concept mapping. And our dependent variable here will be how they do overall in the class as a percentage of the total points in the course. So we have a ratio variable, ranges from 0 to 100, and we have two levels of an independent variable that's between subjects. So this is ripe for doing an independent groups t-test. Here we're going to start with a fresh data editor window in SPSS, go over to variable view, and set up our two variables that we need. You can call them what you want as long as they're legal variable names in SPSS. I'm going to use IV and DV for independent variable and dependent variable for us, just to make it clear what we're doing here. But for the IV, I'm going to label that as condition of the study. Okay. Let me blow this up for a second. And then I'm going to set up some value labels where a 1 is going to indicate no intervention, and I'll add that, and a 2 is going to indicate concept mapping. If you just enter in your 1s and your 2s and you don't label them and you don't give any variable names or variable labels, you're going to come back to your data a week later and see output that's going to be things like var 001 and var 002, and you're going to have no idea what's what. It's worth taking the time to do this. So we have our value label set up, and this is a nominal piece of information. Okay. Our dependent variable is score in brain and behavior, or more generically, score in introduction to neuroscience. I'm sure I misspelled introduction there. Okay, we don't need value labels for this. We do want to let ourselves know it's interval or ratio. So now we can come back over to data view. I'm going to scale this back down so we can see the data here. We have 1, 2, 3, 4, 5, 6, a lowercase n of 6 for no intervention, a lowercase n of 6 for concept mapping. I'm just going to enter in that I have 6 individuals in condition 1 and 6 individuals in condition 2. And I'm also going to go back to variable view and take out the decimal there. I think it's misleading to the reader to think that we have any sort of decimals involved in this independent variable. So this tells me person 1 is in condition 1, person 2 is in condition 1, etc. And now I'm just going to go in and I will put in 79, the 81, 78, 75, 82, 85. So I'm just pulling these right off of here. And I'll do it for the concept mapping, 90, 87, 80, 84, 85, and 84. I'm just going to double check. I know it's boring to watch, but if you don't get the data right going in, you can't get good results going back out. We're looking pretty good here. So each person is in a condition of the study, and we have a measure on their dependent variable. And we're going to go to Analyze, and we're comparing sample means in this case, and we have Independent Samples t-test. We will click that. The variable that is our dependent measure goes into the test variable box. So it's our score and Introduction to Psychology. The independent variable is the grouping variable. Now SPSS has now switched this over to the variable name, and it has question mark because it allows us to use a grouping variable that might have 6 or 7 different values, and it needs to know which two it's comparing in this particular independent groups t-test. So we need to define the groups, saying that group 1 has a value of 1 and group 2 has a value of 2. I'm going to continue. I'm going to click OK. And that is about the fastest t-test you can get if you've ever done one by hand. This is telling us for each of our groups what the sample means are, what the ends are for those sample means, the standard deviations for those sample means. Okay. And then for the independent samples t-test, SPSS gives us 2 different t's, and it takes a little bit of talking to understand the 2. Let's do the easy one first. Ignore this for now. Under the homogeneity of variance assumption, this tells us that we have a t, right, with 10 degrees of freedom that's equal to negative 2.54 and a p equal to 0.029. Right? So this is telling us that the difference between these two sample means would occur roughly 3% of the time if the null were indeed true. Since that's less than a 5% of alpha, we would reject the null hypothesis. This second row is interesting, and if you have a good stats text, it will talk to you about this. We started by talking about the independent groups t-test as having an assumption about homogeneity at the population level. And it turns out that there are ways of actually testing whether it's reasonable to assume you have homogeneity at the population level depending on what your sample looks like. And Levine's test for equality is doing just that. This is a separate inferential test testing the homogeneity assumption. Don't need to worry about this for now. If this p-value here, this significance level, is less than 0.05, you should not assume homogeneity. If it's greater than 0.05, it's okay to assume homogeneity. So if this is greater than 0.05, you can say that you have a t with 10 degrees of freedom that's equal to that. P equals this, and you're done. SPSS has a way of adjusting the degrees of freedom downwards to account for violations of homogeneity, and that can change your statistical significance. It doesn't in this case. And we'll talk more about that in class at some point for students of mine, but for now, this is the way most books would have you generate a t. It's telling us the mean difference between the samples is this, standard error of the mean, actually the estimated standard error of the mean difference between the two independent sample means is this, and we have our confidence interval of the difference. And because that does not include 0, we ended up rejecting the null hypothesis. So thanks for watching, and good luck